Alright, part 2 of this video. We talked about getting in slope-intercept form and graphing them, which we did from yesterday. And I kind of drew that circle of somewhere in that vicinity is a point of intersection. Okay? Now, we did this graphically. We put them in slope-intercept form and graphed them. Sometimes it's not pretty. I know it's difficult to try to graph this on your own because of the fractions. So if you get stuck with fractions like that, I'm going to show you a way that you can do this algebraically. Okay? And it kind of stems from, we have this, I'm going to highlight it again. We have this equation and this equation both in slope-intercept form, and that's really going to help us. Okay, so what I'm going to do is I'm going to copy these two equations that I have in slope-intercept form on a different page here. So let me get the, okay, there we go. Y equals 6x minus 11. There's one equation. And then I'm going to write this equation, y equals negative 2/3 x plus 7 over 3. Okay, trying to remember that. Alright, now, both are in slope-intercept form. Alright, what I'm going to do is set, since both of them or y equals slope-intercept form, I'm going to set each right-hand side of the equation equal to each other. Okay? Alrighty. Now, with that being said, now I can box and line it. Okay? I'm trying to figure out an x value. So let's begin. I'm going to take all my x's to the left, which in this case do the opposite. I'm going to add 2/3 x here. I'm going to add 2/3 x here. Now I don't have a calculator with me, so I'm going to have to do this in my head. 6 2/3 x minus 11 equals, I have nothing else over here besides this positive 7 over 3. And you can bring down the positive sign with it. It ain't going to hurt anything. Okay? Now, we need to keep getting x by itself. I'm going to use a different color. Let's go orange. Let's do the opposite. Add 11 to both sides. Alright? Cancel out. Alright, so now I got 13 1/3 here. I just added those together. Bring your 6 2/3 down. Now we can, let's go green, divide both sides by 6 2/3. Use the calculator if you need to. Okay, we're not going to use graphing calculators for a while. I think it just confused everybody. Now, x is by itself, which is what we want. Alright? X is by itself. And I'm going to divide both sides. I believe that is 2. 13 1/3 divided by 6 2/3 is 2. Okay? Mr. Seidel, you're so smart. I know. I don't like to brag much, but it is what it is. Now, let's look graphically at this point. Okay, I'm going to highlight it in red. Okay, so x equals 2. Now, it's kind of obvious what this point's going to be. So there's 2. Let's find a y coordinate. Alright? Now, to do that, algebraically, you can plug into any one of these two equations, the top or the bottom. Now, if I were you, I would go to the easier equation. So I'm going to use that 6x minus 11, and I'm going to plug and chug what I got for x. So I got 6 times 2 minus 11. That's going to give me my y coordinate. 6 times 2 is 12 minus 11, which is 1. So y equals 1. And guys, you could have plugged 2 in for this x too. Fractions, you would still get 1 right there. Okay? Now, what does that mean? My y coordinate is 1. So where these two lines intersect, okay, inside this circle here, I knew it was somewhere in that vicinity, okay, kind of zeroed in like a target. That point of intersection is 2, 1. That's the whole purpose of solving systems of linear equations. To see if they do intersect, and then where at do they intersect if they do. Okay? Alright guys, we will see you tomorrow.